I've been working on the DM2800 milling machine rebuild, creating 3D printed plastic parts to replace metal parts that were either broken, missing, or in need of a redesign. I'm going to go over some of that process in this video. Hey, it's Pete. Welcome back to the workshop. I do a lot of 3D printing, but it's rarely anything that's purely decorative. Most of what I 3D print are parts that are useful to actually solve problems here in the shop, or very limited run production pieces. I've printed various tool holders and organizers, and in an earlier video, I even designed and printed some enhancements to my Harbor Freight storage cases. I also manufacture a small air valve controller here in the shop that has an entirely 3D printed case. So I started to see what I thought were some opportunities with this CNC mill retrofit to use 3D printing for some of the various parts I needed. In a previous video, I showed the adapter plate I had designed to mount the DMM AC servo motor in place of the original brushless DC motor. After several design revisions, I had a piece that looked great, but as I went to put more of the mill back together, I realized I had not taken into account this motor shroud. It's designed to cover the spindle motor, hiding all the motor connections, and provide a cooling fan. The original adapter plate had separate mounting brackets, and rather than just screwing those brackets onto my adapter, I thought it would be better to integrate them into the adapter design and began modifying my model in Fusion 360. I added provisions for mounting the cover, and while I was at it, I threw in some scoops to allow the fan to suck in air from the bottom. I followed a tip from John over at the John SL YouTube channel. In a recent video, he suggested that when doing prototype parts, only print enough of the part to check the fit before committing the time and filament to printing the entire part. In Fusion 360, I temporarily removed most of the base of the adapter and just focused on printing enough of the part to check the fit with the shroud. After making some adjustments to the design, I did another abbreviated test print to check my screw hole locations, and then went on to print the entire new adapter plate. Trying to cut or even print threads in a 3D printed part is not usually a great option. One or two uses and the threads usually strip out. To get around this problem, you can either leave a recess for a nut in the print, or in the case of blind holes, use these brass heat insert nuts. These can be installed by placing them on the end of a hot soldering iron and pushing them in place. They even make special soldering iron tips for this purpose. One of the common issues I've heard is that a typical soldering iron can get too hot, so in doing multiple inserts, you need to repeatedly unplug the iron, allowing it time to cool down between inserts. There are also ultrasonic tools for doing this sort of work, but I've never seen one made for home shop use. I'm going to try a slightly different approach. I'm going to screw the insert onto a stainless steel machine screw, then heat it up with my hot air gun. I've got the air set to 300 degrees Celsius on my hot air gun. This should be about right. The key to installing these is to get them just hot enough so that they slide into place, without liquefying it to the point where it flows away from the insert and distorts the part. Once installed, it's important to disturb the inserts as little as possible while the plastic cools and resolidifies. These are really reasonably priced and add what I think is a super finished look to the part. I will leave a link to these as well as some of the other tools I used in the video description below. The next item I wanted to address was this motor cover. These cover the stepper motors on all three axes. Similar to the spindle motor cover, they provide a place to make all the electrical connections for the motors, as well as containing a cooling fan. They are also the connection point for the axis limit switches. One of these covers was missing when I received the machine, and I do not have the equipment or the skill level to recreate this in metal. I took some measurements and headed back to Fusion 360 to model the part. This was a fairly faithful reproduction of the original piece, with the only major change being an increase of the wall thickness. The original metal version is about 1 millimeter thick, while the plastic version I created is 2.5 millimeters. And that's just to give it a better chance of standing up to the job. My plan is to put this up on the Z-axis where it really won't be disturbed. I typically print with ABS filament, and acetone is a solvent for ABS. There's a technique called cold vapor smoothing that allows you to remove some of the layer lines from the printing process and leaving behind a smooth, shiny finish. Basically, you subject the part to an environment with a lot of acetone fumes, and the acetone condenses on the surface of the part, microscopically melting it and leaving it with a smooth surface. I want to try that on this part. I cut a piece of window screening that fits the perimeter of a plastic container. I used that screen to trap a layer of paper towels up against the wall of the container. Acetone was poured in and swirled around until it was completely absorbed by the paper towels. The 3D printed motor shroud was placed on a platform in a shallow pan of water, and the plastic container was inverted over it. The water helps to trap the fumes in place. This was allowed to sit for about 20 minutes, and I ran it through the process several times. In the end, I was never really happy with the results. This technique does work, but I don't think this particular part is well suited for the process. With only a 2.5mm wall thickness, this part started to soften to the point I was concerned about it losing its shape. The sidewalls started to bow in a bit, and I pulled the plug on the whole operation. After it regained its firmness, I broke out the sandpaper, primer, and paint. And I'm really happy with how it came out. Matter of fact, I thought this piece turned out so nice that I had to go back and sand and paint the original metal covers as well. I also replaced the fans with all new 24-volt ones while I was at it. I wanted to degrease and clean up the flexible conduit that runs to each axis before putting them back on the machine. I soaked these for a few days in a container of purple power, occasionally scrubbing the tubing with a brush as I walked by. After removing the tubing from the container, I let them hang and drip dry for another few days. I wasn't really in a hurry for these parts as I was working on other things during this time. And just a quick shout out for this hand pump. It's super cheap and works surprisingly well for this job. Once you start the flow with a few pumps, it will continue to siphon on its own. Again, I will have a link down below where you can check this out. Once the conduit was dry, I went back with a brush and removed the powdery residue that was left behind. The Y-axis conduit had a crack in it, Based on where it was located on the machine, I'm guessing at some point in the past something fell on it and cracked it. I looked around for replacement conduit and fittings, but then started to think maybe I could just create a splint to cover this crack. I envisioned a two-piece tube that would close around the conduit in a clamshell fashion, supporting the cracked area while not looking out of place on the machine. I sketched up a design that could be printed in two identical pieces and then pinned together with pieces of filament. I think it came out really well. One quick change I wanted to mention here. In the previous video where I went over the electrical panel, I had originally installed a 24-volt 100-watt power supply. Based on some comments from Marty's CNC Garage, I swapped that out for two 60-watt 24-volt power supplies. One of these power supplies is going to be dedicated to powering the Acorn and the Ether 1616, while the other power supply will be used for external loads, such as solenoid valves and relays, things like that that might make noise. If you want to follow along with this milling machine rebuild from the very beginning or at any spot along the way, click that playlist and I will see you over there.